Oh, maybe. Let me see if I can. I actually used the Starbucks, what do you call it? Sleeve for your cup once to make it work. We can use you and you. I think it would work. I think it would. Make it work. It wants to work. Aha. Aha. All right. Let's see how long that stays. Well, that was exciting. So 33 where, sorry? 2-1?
2.1, section 2.1.
33. Oh, good. Yeah, this is the...
So the first part is with why can't the graph of yx cross the graph of the equilibrium solution, y equals c, is that because there's asymptotes?
All right, you ready? Yes, that has to do with it. Yes. So 33, what's interesting about 33 is a lot of the questions are related. Once you answer one of them, you basically have most of the answer for another one of them. 33, if you haven't done these yet, this is section 2.1. Suppose that yx is a non-constant solution of the autonomous equation dy dx equals f y. And y of x is a non-constant solution, some function of x. Why can't the graph of this cross over the graph of the equilibrium solution y equals c? So like, maybe they're saying there's only one. So yeah, you have to go back to how you put a phase portrait together. Why is it an asymptote there? Really go a little deeper. Don't just say because it's an asymptote. Why is it an asymptote?
That's where the critical.
True, and the critical point is the only point around which certain things can happen, which will answer part of the next question, right? So this is related to that sine diagram, right? I mean, if I know where something goes through the y-axis and it's 0, 2, and 7, and then it can only, then it has to be above or below it for all through here, right? So that's related to this now. It's related to that idea. So you just have to be careful to say enough to answer the question. Don't just say, because it's asked, you got to go a little bit deeper. Why is it an asymptote? Why? So you're on the right track with what you just said. I don't want you to give too much away before everybody. So the problem sounds really difficult, but then you realize there's one or two key things that we discussed that answers all the questions, really. You just have to make sure you really, don't just say, because this. No, you got to really relate it to what the question is asking.
Just because there's just like a bunch of different notations in that section. Like they have like f of y, and then y of x, and then f or y, f of y equals c. There's just like a lot of notations. So I got kind of.
I gotcha. Yeah, and that relates to, if I'm in this class, I'm a little worried about the fact that there are answers that if I forget to do something, I won't ever get them. I don't know if that's in the back of your head. It should be. So every time we learn a new way of doing things, we've got to address how do we make sure that we get the entire collection of answers, right? This one, though, once you realize that this is where it's 0, so one side or the other, it's got to either change sign or not change sign, and that has to do with whether it's stable or semi-stable or not stable at all, right? Remember that kind of stuff, hopefully?
Could we just call that a tractor, or do they want to say stable or semi-stable?
Oh, so
the
the semi-stable stuff, of course, is going to be weird, right? But yeah, the attractor, the repeller. So I'm going to be a little specific on the quiz as to what I want to see. But we talked about in class about how we call it a tractor. You could call it something, but it's really just an attractor. You could call it this, right? So in general, if you say stability versus answering a tractor or repeller, I'll accept either way because
there's no difference.
Yeah. So here, if this is but the minute you realize what I just said, this is where it's 0. So on these sides, it has to be not 0. because this is the only place where it is 0. And the only place you could change sign is around this 0. Once you realize that, that answers almost every question in that problem. I don't know if you've tried that problem out yet. I don't know if you see that title discussion problems and you go, maybe later. It sort of reminds me of like synthesis or something. I always have that. They should just call it even harder problems than normal. This one isn't that bad. 36 is a lot more interesting. I don't know if you've tried that one out yet.
Oh, I had.
You did? Okay.
Oh, yeah, we have. Yeah.
Okay, cool. I like it. 33 sounds like it's really hard, but once you realize that basic idea, it answers most of the questions. Okay. Anything else from homework stuff? I mean, just to let you know, you should be at least getting into 2.2, if not into 2.2 already. We took a baby step into 2.3. To be honest, I don't think we did discuss. I just laid some of the groundwork, I think, about why we're going to do what we're going to do, and why we would even think it would work. We haven't talked about what the hell it is yet. So anything else from homework? You guys all right otherwise? Or you just don't want to let me know? Okay. Let me see. Dan came in. Where'd you go, Dan? There. Anybody else after their quiz back? What's your name? You guys can make corrections, read through the syllabus for those instructions. So I think last time we got to the point where we set this back up a little bit. I want to use some similar stuff with the book, so if you're trying to go back through the book, it kind of relates to what we're doing here right now. If I remember correctly, at one point I had this form of this up here, right? And we realized that if A0, I don't know if you guys remember this, or the whole point is just trying to write this as the differential of something. If A0 equals A1 prime, then that's I have this product rule, don't I? It's basically a product rule then, right? If A0 equals A1 prime, then I've got basically dA0y. Because what would this be if you took the derivative of this? All right, this would equal g of x dx, right? So let's do this. Let me put this back over here. What if you did this derivative? What would you get? Remembering that A0 is a function of x, right? So that's why this kind of works. When you do this derivative, what do you get? So here you got a function of x times a function of x. So what's the derivative of A0? A0 prime y plus A0 y prime, which is really, I got this thing the right way around. Oh, did you say this the right way around? Oh, I got the wrong symbol here. This is good, Jeff. If A0 is A1 prime, I want A1 here. So watch this. Oh, here we go. So this will be A1 prime y plus A1 y prime. So there's A1 y prime, and there's this. As long as A0 is A1 prime, this is true. Okay, let me stop there for a second. So just trying to use the symbols I was using last time, right? I wanted to connect the symbols we had used before, and now I'm going to use the symbols that the book is going to use in this section. Try to make that connection. It equals, anyway, that's this part. It equals 2x, blah, blah, blah. So the whole idea is, if this is not true, then this is not the reality. And why would this be a really nice reality? Why, if this is true, why is that nice? Because I can write this like this if that is true. And then what could I do off of that? Why is that such a great thing? Because now I've got this, right? This is just kind of a check, really. I've got this. What would I do? I could bring the dx back up, and then I can just integrate both sides. And the integral on this side, I'll do that. There you go, I'm done. Yeah. Equals, and hopefully g is nice. There's an example at the end of the section that I might go over that talks about what if g is not integrable? Well, then you're going to have an answer in terms of an integral function. Sort of like just going, well, shit, I can't do it. So here's what it would look like. All right, let me stop here for a second. Now, how often will that just like happen for us? Not very often, no. So we want to investigate. Is there a way to force that to happen? So is there a way I can change what these are to make what's there work? To make what's there allow me to write it like this? And this is what's called an integrating factor. Can I multiply everything by something that will put it in the right form so then I can write it like a total differential and I can integrate easily? Okay. So let me bring it back into, so this is the idea. If this was true, it would be easy as shit, or easier than it might look at first, okay? Depending on this little dude, of course. So let's bring it back to the types of things you'll see in this section. So let me write the official thing here, and then I'm going to write the way I'm going to write it. I think that at one point, for some reason, they put an F here, so we'll just go with that. In the section, what is this, 2-3? Let me write this for shorthand. All right. So what I want to do is I want to, and the symbol that we use very often, has anybody ever taken any statistics? Anybody taken statistics? What's the symbol for the population mean? Do you guys remember? So I always call it a French cow. No, that's sample mean. Population mean is mu, right? U with an extra leg. You with me? So that's just the standard classic from the beginning function. So we're going to multiply by some function of x. Multiply both sides by some function of x, and hope to God that what ends up happening is the coefficients end up doing what we want them to do. So how are we going to do that shit? Well, we're going to just do it. There, let's pretend like we already found it. We're amazing. Okay. It always feels like cheating, but what we're going to do is we're going to work it backwards to see what mu must be. What must mu be related to? Is there a way to find it based on what I see in my equation? So what did we say earlier? Just to remind you guys, if I had, what was this? Yeah. If I had a1 y prime plus a0y equals, what was over here at that point? G, doesn't matter. If if a0 equals a1 prime, everything's great, right? So if mu p, that's like the a0 from before. If that equals a1 prime, let me go ahead and write this officially. Then we're golden, right? So now I can use this. Now let me stop there for a second. So that's exactly what we were saying before. If a0 was a1 prime, then this would be just the definition of the product rule. So I could put it back together, and then that side would be easy as shit to integrate. Let me let that sink in. So this is what it looks like more officially with everything. Now, how do I solve that? I've just created its own little. You gotta love this shit. It's like diffecuception, right? It's a diffeq equation from a diffeq equation. How do I solve this? You're not going to have to do this every time, thank God. We're developing a method. So we're trying to figure out, how do I figure out what mu is? What process can I use to solve this? We're in 2-3, so that means we are assuming we know 2-2. Separable. I love it. So what would it look like if I separated stuff?
be on the other side, yes.
Yeah, so I'd have to divide mu over. Right, and then I can multiply dx up. Is that cool? Got it. Become a mu. So that's the separable part, right? And that's the first thing. What I always tell students is assume it's easy, and then if it's not, then maybe it's a little harder. So the first thing I always look for a differential equation is it separable? Because if it's separable, I can just attack it with, I'm back in like 280 at worst. Just attack it and you're like, well, that's pretty bad. But oh well, it's not as bad as it could be. Now integrate both sides. What do you get? And then this you can't do or shit, right? It's fine, don't worry. Because we don't know what the function p is. And again, we're developing a process that will work. What is the answer going to be dependent on? It's going to be dependent on what p is, what that function p is. Which on some level should make sense. We knew that from the beginning. It's got to sort of relate to that because we're trying to fill in this guy's gaps to make it kind of work. Or, the other way around. Okay. So now, how do we kind of solve for mu? By the way, I'm kind of like, there should be a plus c here, right? That doesn't matter. It doesn't because it's going to become, I don't know if you remember, when you do e to this, it's going to become a constant multiplier of e, which would divide out anyway. If I multiply everything by it, the c's would all divide. It wouldn't really do anything to me. So I can just choose c to be gone. I can choose c to be 0 right now, or once I do it, I can choose it to be 1 as a coefficient of e. So the c, I don't have to make the c anything. I just make it not be there anymore. Doesn't matter what number I pick for it. So this is how I figure out what I multiply by to force it to be semi-easy, right? I can write at least one side will be easy. So let's try a concrete example, right? We're all like, please, dear God, Jeff, stop with theory. This is kind of nifty, and I don't know if you guys understand what just happened. We assumed we found the answer, which means that it did do this. And if I work this backwards, I see what the form of it must have been. I love that shit. It's basically what algebra is. What's the answer? Well, let's say it's x. We'll do some shit, we'll figure out what x is later. Right? It's mu is the answer. And then we do some shit, and we go, oh, that's what mu is going to be. There's no magic here, really. So let's do a specific example. Let me see what kind of weird example. Yeah, you would pick that one, Joe. Well, let's try it. So everybody got this here? This is the derivation. You're never going to have to do any of this again, because it's already been done. Yes?
Is p going to be given?
P is the function that's here once it's in this form. Right? If you put the differential equation in this form, and of course, what kind of differential equation does it have to be? We're in section 2.3, which is titled, what is this the form of? What kind of differential equation? Linear. Beautiful. So it's got to be linear, but if you take a linear first order differential equation and you put it in this form, whatever the hell this coefficient is going to be p. You gotta love that. All right, so let's try one out. Let me leave that there and this there. And let's see, here's the example I picked. I think I just picked this at random and it gets interesting. So, what's semi-wrong about this at the moment? I just know somebody's out there like, it's all wrong, Jeff, on some level. What's the most immediate thing that's in the wrong place according to the form it's supposed to be in? What's supposed to be first? dy dx. So what's in the wrong place? X. Okay, cool. So just divide by x. So now I get dy dx, if you want to write like that, plus 1 over x plus 1. Is that cool? Times y equals this yumminess over here. I don't care if you put the e on the bottom or the top, who cares? So in order to do the method, You have to have a first order linear differential equation. Most likely, it shouldn't be separable, or else why the hell am I doing this? You guys understand that? If it's separable, yeah. There are situations where it's actually easier to do this than to separate it, to be honest. Which sounds like, no, Jeff, but it happens. What do I have to identify to be able to do this process? P. I just got to know what P is. What's P? Yeah, so this is P of X. So how do I figure out what it is I'm going to multiply both sides by? I just do e to the integral P dx. Is everybody cool with this? You integrate, and that's just going to be your exponent on e. Whatever that integral is, e is to that power. So I get e to the integral, 1 over x plus 1 dx. So take us, I got to figure out what that is. What do you get there? You get mu equals e to the ln x plus x. I like it. Don't worry about the plus c. It's already, we don't care about the plus c stuff. Because it would just be a constant multiplier that we said earlier we don't need. And how do you kind of clean that up a little bit? Not currently, not the way it's written. E to the ln x times e to the x, because we're adding exponents, we must have been multiplying bases. So mu ends up being x. X e to the x. I like it. So if I multiply everything by x e to the x, what happens? Let's see. So we're going to multiply both sides by mu, which is x e to the x, x e to the x. Now the diffie-q's that work this way, a lot of them inherently do what's about to happen. Is what is about to happen, is it always going to happen? No. But here it's going to happen. I mean, very often it happens. So it's not like a completely contrived thing. What am I talking about? Well, look at this side. This side kicks a lot of ass, because what happens? That goes away. That goes away. Oh, shit, yeah. That was really concerning. It should have been concerning, because eventually you're going to have to integrate whatever the hell's on that side. And you're kind of like, come on, you. Get rid of some of that crap.
You just multiply both sides by 2?
Yes. Beautiful. I like it. And then here you get, oops, that's the mu is. You get x e to the x, let me just write y prime, plus, and this was 1 plus x over x, right? So you end up with 1 plus x e to the x y. Now, to be honest, you actually can sort of skip this step once you get more used to this, because the next step is always going to be this kind of thing. You can write this as d what? So I really want you to notice, it's always going to have a y in it. You see the form? That's y prime, that's y, so that's the product rule piece that kind of motivated this possibility in the first place, right? So it's always going to have a y piece. And then this is just going to be x e to the x. It's going to be mu. So this d blah blah is going to be mu y. It's too beautiful to believe. I don't know if you guys understand what's happening. Yeah, so always, when you do this process, the step that we're at is always going to be this. We've designed it to be that. Most of the times. Right, now here, so what is it? X e to the x, y. Okay. equals, now I kind of already took the dx, is that cool? So the dx over there, is that decent? You guys with me? Y prime is dy over dx. Multiply the other side by dx, and I got this little dude here. All right, let me stop there for just a minute. In case you're having some trouble, verify for yourself. Can you guys see that the derivative of this is this? So derivative of y is y prime. Leave the first piece alone. What's the derivative of x e to the x? Well, it's going to involve a product rule. It'll be e to the x plus x e to the x, which is this. I love it. We forced it to work that way, so it shouldn't be a surprise. Now all you got to do is what? How do you get to the answer here? Integrate. Yeah, so I'll do this side. Whew. Okay. And that side shouldn't be too crazy. I love when people try to start bringing out identities and shit. No, it's just integrate sine with a linear thing inside. Who cares? So what do you get when you integrate sine? Yeah, I like it. So it'll be negative cosine of this divided by what this would let come out. I like it. Now you got to do plus c. Yeah. Why were we allowed to just make c whatever we wanted to? Because the mu is something we're introducing to the problem. It doesn't matter what the c is then. Why do I have to have this here? Because it's a part of the freaking answer now. Right? And we're not even done yet. Right? So they get y equals, just divide by x e to the x, right? So you get negative cosine 2x over 2x e to the x plus c over x e to the x. Wow! Well, just to introduce another piece of terminology, what happens, let me ask first, is everybody decent with the steps here? The only new thing we've introduced is the idea of this. And can you imagine where sometimes you're not going to be able to really figure this out? I mean, if I just get this in terms of, I can't integrate this, well, that's going to kind of, make things really difficult. But, depending on what P is, I should be able to get something over here. What was it? There's something else I was about to say. I want to introduce a new definition. What happens to this answer as x gets really big? Yeah, the whole thing disappears as x gets really big. So any piece of an answer where it goes to 0 as x goes to infinity is called a transient term. So if you're dealing with, if any of you have ever done any electromagnetism or something, you might have something related to transient voltages or transient currents or something. They just die out over time, normally really fast, right? So you have these what's called transient terms. And normally it's something like e to the negative x, or, when x gets really big, it goes to 0. Where do they talk about that in the book? Page 59. Blah, 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 blah. Okay. So that's it's not something that's always going to happen, but just in case it comes up, that's what a transient term is. Right? Later, it's going to have a little more importance with some stuff we're doing, but right now it's just kind of like, oh, that's interesting. Okay. Oh, cool. Let's do another example. I mean, that's basically the idea. Let's do another example, and then I'll talk a little bit about, is it here? No, it was in the last session. Well, maybe I'll go back and talk about that. Let's do one more example. Let's see. Should we go what they want from here? Yeah.
What did you do when you went, just before you did the integration? How'd you, what did you do in that step as it comes down to the.
Oh, here to here?
Yeah.
All right.
Is that just right?
So when let me see if I can say this in general, and it's not, I'm going to say this. Yeah, okay. So when I multiply by mu, I'll get this here, right? Mu p of x, y equals f of x mu. Is that cool? Right? Then this will be d. Other pen. What's this going to have to be? This is going to have to be, because remember, this is going to become, let's see, I'm trying to write it in general so you guys. Let me see if I can let me figure out how to say this in general so it makes the most sense. Oh, okay, amazing. This is going to end up being mu prime. Right, that's what the whole purpose was. Remember, mu p was supposed to equal mu prime. So if we do this procedure, we multiply by mu p becomes mu prime. So how can I write this then? What is this the product rule of? Well, I left mu alone here, and I left y alone there. So it's got to be mu y. So this step, to be honest, is sort of an extra step if you really look at it. I mean, I'm not saying to skip this step necessarily, but that will become mu y after you integrate it. That's how we designed it to work. A few of you guys are with me on that.
Oh, that's right. Okay.
That's how we designed it. That's how we created mu. Yeah, I like it. Okay. Is that cool? So that's how I went from, so really just looking at it would be a little bit harder, but I can see the y there and the y prime, so y's got to be a part of it. So this has got to be the other part of it, and I can just double check by making sure that this is this guy taking derivative of, right? I can just check that. But it's got to be true if I did this correct. That's got to happen. We can just kind of make sure that you actually did this right and everything looks good. You can take a second to make sure that derivative is this. I love it. You guys see that? I really want you to understand. This is, at the heart of it is, how do I turn this into the result of a product rule? Because then the integral would be stupid easy. It would involve doing this, which is the best integral I have. What's the integral of dl? L. It's awesome. Please let me get more of those. So that's the whole purpose of this. All right. So let's do another one. Let's see if I can pick one out. It won't be too easy or too freaky. It looks the same as what we just did. Yeah, let's try this one. Here we go. This one shouldn't be too crazy. All right, so try to do that problem using an integrating factor. Anybody not get their quiz back yet? Did you get your... Maybe one that wasn't too evil. Okay. Try to catch up with you guys. Real quick thing to point out. Where's P of X have trouble? Yeah, so X can't be 0. So far my intervals could be negative infinity to 0 or 0 to infinity, right? So how do you get your integrating factor? What's P of X? E X. So mu is equal to what? E to the
4
integral 4 over x dx. Yeah, 4 natural log of x. And don't worry about the c's in this little intermediate interval.
4x.
Oh,
4x e to the natural log is e to the natural log.
so what do you have to get out of the way? You wish that the e gets in the natural log, but what's in my way? Stupid 4, but of course you can take the 4 up here. Right? Good old logs. And then you don't need the absolute value, which we pretty much ignore for a while. So mu equals x to the 4th. All right, let me let that sink in. Damn properties of logarithms, whatever. Another way to look at that real quick, if you had e to the 4 natural log of x, isn't this e to the natural log of x to the 4th power? Because you multiply powers when you're raising one to another. So e to the natural log of x to the 4th. Oh shit, you got the same answer. Okay. Then what do? You multiply everything by x to the 4th. So you get x to the 4th y prime plus 4x cubed y equals x to the 6th minus x to the 4th. What's the only thing about this side that I really have to be careful about? I mean, I don't know if you noticed, it was a sign just a second ago. Now it's a polynomial. The only thing I really got to be careful about when I put it in this form is that this side has to be what? What has to be true about this side? It can't have any what? Can't have any y dependence. It's got to be purely a function of x. Because they will give you some that are just written totally out of order with stuff all over the damn place. I'll give you one. We'll do one here in a second. Is that cool? It's got to be a function of x on the side. In that case, it doesn't matter what the hell it is. How it's going to affect my answer when I integrate it. Yes?
Is that e to the integral p of x, is that just something we can use for, like, in general?
For when? When I have a...
For mu, or, like we're not going to have to rederive that mu.
No, definitely not. But I can only use it when I have a first order linear diffie. I like it. And even that procedure isn't necessarily guaranteed to work, because it won't always be able to integrate p dx. What do you get here? So this side will be
e to x to the 4 y.
x4y, mu y. Is it pretty cool with the fact that I do this? The minute I rewrite this as d something, that dx part, I'm multiplying it up to the other side. Is that, I mean, hopefully that's cool. And then integrate. I'll do this side. This side hopefully is trivial. So your y equals, just divide everything by, just lose 4 x's right everywhere. Any transient terms? This is the answer. Any transient pieces to that?
As x goes to infinity,
Yeah.
y gets 0 because of x.
Yeah, so this term is the transient term. I like it. Don't judge him. I mean, he's had a rough life, so you'll work it out.
Can you repeat that again?
Since this term goes to 0 as x goes to infinity, this is officially called a transient term. They're pointing it out
That'll
now.
just
Go
become
ahead.
0, right?
Because it becomes 0 as x gets really big.
And how will that affect fall?
It doesn't. So right now, we're not too worried about transient terms and what that means and how that affects anything. The reason they wanted to give us that definition, that word, is because this is where we start picking them up more and more often, right? So later, a term being transient is going to mean something more to us, but not yet.
So it's almost like a series. I remember how to actually took like the bottom one because it goes to infinity faster than the x cubed.
No. I thought maybe you were. It's got a little bit of something to do possibly with series solutions to things, but no, not like that. Okay. I'm not going to say any more about it because we're not going to worry about it yet. All right. How do you feel about that? I mean, this is actually now a little bit okay. All right. I want you to realize once we get to talking about all these, one thing that's nice about 280. I know most students hate 280, but one thing that's nice is when you have a class. And this is what I love about DiffQ, and also what I kind of don't like about it is it's so recipe-ish. If you know what to look for, you know what to do. If it's in this form, you try this. If it's in this form, you try this. One bad thing is a single DiffQ could be in 3 different forms at once. So, and if you pick the wrong form to try to do, it's going to be the hardest way to do it. I mean, so we try to start to develop, how do I tell which way is going to work the best? Or if I start doing something, is there something I can look for that tells me, oh shit, try it a different way? So once we know all of them, then we'll start doing mixtures of stuff. So I'm going to have a handout in our future once we get all of these forms under our belt. We just have to first identify what forms it's in and then see if there's a difference between how we solve it. Right? Okay. Real quick, let's do one more and then we'll do one more section and then we'll call it a day. This class goes by so fast. Is that true for you too or no? Yes? Okay. So you guys are like, it's like time stands still. All right. Where were you? There you are. Look at this one. This is interesting. It's number 20. This might be homework. Who knows? You're always appreciative if it is. So again, the form of a first order linear differential equation. It was Q before and they made a G screw, or F, or whatever the hell they did. It's just some function of X over there. That's the form it's got to be in. So there's two things now. The first thing is really obvious. It's the same thing that's happened to us a couple times in a row now. Right? Whatever the hell that is, we've got to divide by it. But what's got to be pulled over? All the Y pieces have to be pulled over. What definitely has to stay on that side? Well, any x's are, no, not any x's, but, I mean, it's going to have a coefficient of x here, right? 5. 5 is a function of x in a really weird way, right? It's not a function of y, for sure, I don't know, I guess it. So what's got to be true about what I put here? Got to have a y. Okay, so I'm going to leave the 5 on that side. Let's see if we can do all this. Let's first bring that stuff over. Make sure we got it written correctly. So it's going to be plus 4x plus 8, right? Because I add the 8y over, I add the 4xy over. Is that cool? So everything's positive. And then I just write it to be like this so I can see what p is. Or eventually I can see what p is. Let me stop here for a second. Is that decent? All right. Sometimes you're just thinking about something bad and it shows up on your face. I think, did they not understand it? Now, this has got a little bit of weirdness to it. I don't know if hopefully you guys notice it. What we have to do now, divide by that thing, right? But what happens there? Math 90 happens there, right? Yes. You can factor this in one of the x plus 2's. You guys see that? Definitely reduce the shit out of that if you can, right? I mean, it doesn't matter if you do it now. When you set up the integral, hope to God you recognize that so you're not trying to do some weird thing to it. That would so suck. All right. So now take a minute and try to figure out what the integrating factor is going to be. Really make sure you guys understand this is a 4 here, right? Some extra y. Oh, eventually, yeah. Okay, sorry. You just went straight to the end. I wanted the intermediate stuff. This integral is going to be 4 ln x plus 2. X plus 2 is x. Oh, do you understand what I mean when I say that? It's linear, slope 1. It's x. Shit, you just carry the plus 2 with it. Does that make sense? I don't know. I hate when people try to start doing weird shit to this. It's linear, slope of 1. You can't beat that. Then you treat it as if it is x. You just carry the expression around with you. So then the 4 goes up here like it did before. Those go away. So my integrating factor is x plus 2 to the 4th. So I get x plus 2 to the 4th, y prime, plus 4 times x plus 2 cubed, because one of them dies. Poor little dude. 5 times x plus 2 squared. Massacre on that side. And this is going to be d yeah. Left alone there, pop. Left alone there, pop. Derivative of that, pop. So you kind of check as you go. Equals 5 x plus 2 squared dx integral. I'll do this side. It's just as funny as the first time you said that, Jeff. Not at all. And again, that side, x plus 2 squared is x. How do you integrate x squared? It becomes, yeah. So it'll be 5/3 x plus 2 cubed plus c. Is that cool? No, u sub would just be u equals that, du equals dx. I mean, that should tell you you don't need u sub. So then what do? I divide by this to solve for y. So you get 5/3. It doesn't matter how you write this. I'm just going to write it like this to be different. Plus c times x plus 2 to negative 4. Any transient terms there? Sure. And the whole damn thing is a transient thing, right? All the terms of that poor dude is transient. That's 1/x plus 2 officially, right? So they'll both go to 0 as x gets really big. All right, I like it. So the homework does ask you to identify the transient terms. And real quick, what's the problem with p of x and q of x? What's the problems here? It can't be -2, so you can identify the intervals over which it's defined as part of the solution. I like it. Okay, so moving on. I want to at least lay the groundwork for 2-4. And I keep saying this, and I don't want to make you feel bad that this is not true. But if you've taken 281, this is, you should already have this down, what we're about to do. If you are going to take 281, you'll be annoying in that class, because when everybody else is like, what the shit is this? You're like, oh yeah, that's just exact. Yeah. Which is exactly what happened last semester for some people. All right, so what we're about to get into is, it involves some partial derivatives, but I gave you the handout. Everybody pretty much said you were pretty cool with partial derivatives, so I'm going to go off of that knowledge. Let me start off with a concrete backwards thing. I'm going to start with the answer. We're going to make a diffie-q from it. And how do you make a diffie-q from something? Just take a derivative, right? Or take another derivative if you want to. So if I gave you this, can you do the total differential of it?